There were just some things from last week in the presentation that I didn't completely cover. There are some things in the, how should I say, it's like sometimes people like to save keystrokes as if they were being charged for them. And so some kind of almost useless features come in. This in my opinion is one of them. When you're initializing an array, you can do it in one of two ways. One is you can instantiate the array, and then you need to set all of the individual values. That's important to remember. And that's usually the way it's done. And when it comes to actual serious programs, that's the way it's done. In our main methods, we've been just sort of writing what amounts to tests. And the thing about these tests is that they're throwaways. The keepers are these component classes that we write, like the die class, like the card, the playing card, all of those. Those are keepers in the sense that they can be used and reused. But the main is, at least what we've been doing so far, is basically a throwaway, because it's really just kind of testing what's going on. This feature, this initializer list, without saying what it is one of those questionable features, because it's got such a limited applicability. So basically, in a main method where you're testing stuff and you don't want to do all the extra, instantiate the array, then set each individual value. Suppose we know, in this particular case, that we know, we know, so you're going to give me the pen. We know that these are the values that I want to test. In an application, you're typically not going to do this. If I have these values, I'm usually going to read them in from a file somewhere. And if I'm reading them in from a file, then I have to do it the old way. That is, instantiate it and then set the values one at a time, usually in a loop. We now know how to do loops. So now, if I'm writing this, the normal way would be to say, I need to instantiate a new int bracket in front of this. And they said, oh, that's so much typing, it hurts our fingers. So they added the feature where one time only you can set the array equal to a bunch of stuff and it'll figure out what it is without having to do this. Okay, so and in your main methods, if you want to do that, that's perfectly fine. But just know that this is one of these, in my opinion, pretty useless feature. It saves 1, 2, 3, 4, 5, 6, 7, 8 keystrokes for like a little test. Now again, for these tests, it can be helpful to, if you know what the values are, to just be able to kind of set the array. That sets the array at once. So you don't have to say new, you don't have to specify the size. But that, again, this is something, okay, in their little example. Okay, if you happen to know what the first 8 prime numbers are and type them in. If you're working with prime numbers, though, then dealing with the first 8 where you actually know what they are is not a terribly useful thing. If you're working with prime numbers, then you will typically have some kind of algorithm that will start picking out the prime numbers. Again, that's a little beyond what we're about in this course. The other thing which I mentioned in passing but bears emphasis And this is, you can pass a reference to an array as an argument to a method. This is where something I said earlier in the course really can be helpful. It was helpful to me, so it may be helpful to you to understand what happens when we pass an argument to a method as a parameter. What happens is, the rule to remember is that it creates a copy of the thing that it's passing, thereby creating essentially a local variable inside that method. If the thing you're passing is a primitive, then the consequence of that is anything that happens inside that method does not affect what you pass to it. Okay, that's important to understand. Similarly, what gets if you're passing an object, and an array is an object, if you're passing an object, what gets passed is a reference to that object. And so what gets passed is actually a copy of the reference to that object. So if you change that reference inside the method by, say, having it point to something else, it will not change the place where it was called from. However, since it is a reference to an object, in this case, if you pass an array that is a reference to an array inside of a method, and in that method you change one of the values of the array, that will happen. Okay, now think about that for a second. Does that make sense? In other words, if I pass a reference to an array, it will create a copy of that reference. That copy points to the same object. It points to the same array. And so if I change an element in that array, I can't change that reference outside of the method. But once I have that reference to the array, and I change one of the elements in the array, that element will change when I come out of the method. Do you see that? Does that make sense? Okay, so the behavior is going to be a little different depending on whether I'm passing a primitive, in which case nothing gets changed, or if I'm passing, say, an array and it can change the value. That also applies if I'm passing an object. If I pass an object, it'll be a copy of the reference to that object, but it'll point to the same object. If I invoke a method inside that method on that object, then it will do whatever that method does. And if that method changes the state, so for example, if I pass a die object to a method, and inside that method it invokes roll, then it will roll that die that I passed in. Okay, so, but if you understand, if you kind of remember that what gets passed is a copy of the value, and the value of a primitive is its value, and the value of an object is its reference, so that that reference is pointing to the same object. Okay, does that kind of make sense? So that was all from last week. Start on this week. Let's see, all right. Okay, so today we're going to delve into this array thing. Arrays are very important. You've dealt with arrays in your previous languages. As I hope you see, though, one of the differences is that in Java, arrays are fixed size and have bounds checking, meaning that anytime I try to put something into an array that it can't handle, I get an error. In contrast, in other, especially scripting languages, if I have an array and I want to put more stuff in, it'll just gladly put it in. And if I have an array and I say, well, okay, I want to put something in index 100, even if there's nothing else in it, it will gladly do it. Java is not like that. Now, in Java, Well, okay, getting that arrays are objects is kind of important because there are methods and instance variables associated with arrays that can be invoked. Remember, objects are have instance methods typically, and they have methods. As we will see, or if you haven't seen already, Java already has an instance variable called length, which on the surface tends to violate encapsulation, meaning that it is public. It does not violate encapsulation only because arrays are fixed. So it can't be changed. And once it can't be changed, it's essentially a final. So a final instance variable is kind of okay. Although it has, if I were designing it, I would have made it a method. And in fact, Java made it a method when it came to a string. So that can be a little confusing. So in an array, there is a length instance variable. In strings, there's a length method. And in strings, the length method tells you how many characters in it. In an array, the length instance variable tells you how many elements are in there. And now the book has kind of as a nice example here, where there are a number of different classes. So far, everything we've done, there's just been like one class. And so this is an example where not only are there several classes, but there are multiple instances of one of them. So that's okay, so this is something I was, again, it says the entire array, that's a little bit of a misnomer because it does not pass the entire array, but it might as well have, because once you have a reference to the array, you can do anything that you can with the array itself. So, but it doesn't pass the entire array. That, for historical purposes, like in C++, you had to be careful because in C++ you could literally pass the entire object to a method, and or a reference, but you had to say which one it was. And after a while, they realized that passing the whole thing to a method was kind of wasteful. And so they kind of gravitated to only passing the reference. And so Java came along and looked at that and said, okay, there's only one way to pass an object, and that's going to be the reference. End of story. Now, we can pass an individual element to the array. So if I have a single dimensional array and I pass the one at index 3, say, then that would be either a primitive or an object, depending on what the array was defined to be. So we can define an array to be an array of objects. In fact, any class, whether it's a built-in Java class or a user-defined Java class, can be used to define an array. So here we have an array of length 5. Okay, and this is important to remember. It doesn't create the string objects themselves. So, and this is important to remember that in fact, the thing to remember is that when you instantiate an array like this, and most of the time, except for just a few very little test cases where you're doing that initializer list, this is in 99% of the time, this is how you're going to create an array. 99% of the time. The thing to remember is that when you instantiate an array of any kind, the values of those items are the default values of whatever they are. And there are a handful of possibilities. If it's an object, the default value of an object reference is null. So when it's declared, that's true whether it's declared as an instance variable or as part of an array. So in this case, after this statement is executed, there is an array of size 5, indices 0 through 4 have the value null, and null means nothing. If it's a primitive array, then the initial value is the default value of that particular primitive type. If it's an int, for example, the default value of an int is 0. So if I instantiate an array of ints, before I assign anything, they will all be 0. The default value of a double is a 0 double, which is actually a different thing. And likewise, if I instantiate an array of doubles, they will all have the value of 0, double 0. The default value of Boolean is false, so if I instantiate an array of Booleans, then they will all be false. Okay, this is a nice way to sort of think of it. In other words, when in this particular case we've instantiated words, and so what we have done is we have created a reference. So what Java does is when you run it, it goes somewhere and finds 5 spaces for this array, and it creates this reference which points to where that is. And so how big should they make this? Well, big enough to hold an object reference. So that's basically one word. Now at this point, so if I try to print, well, this is actually false. I should have checked this. This is not. This will actually print null. We can check that. Remind me to check that. Okay, so now, why did you create an array of strings? Well, because you wanted to put some strings in there. So you need to actually put the strings in there. So here we would say word 0 is equal to friendship, words 1 is loyalty, honor, etc. Now this, we can create them using literals. Oops, this should have been a bracket. So this is kind of my preferred way, but if you want to leave this out, then again, that's fine. Okay, so they have this grade example. Okay, so, and this is actually kind of more akin to what in other languages is called a strut, but anyway. Very simple class. Basically, you have what they call the name of the grade, which is going to be like, A, B, C, etc. And a lower bound, which is an integer, which says what the cutoff is for that. So all this are just these name. In fact, let me just look at this is in the code. So I trust that everybody has been able to pull the class code stuff, okay? And if you ever have any difficulties with that, shoot me an email. Okay, basically I tweaked this a little bit. First of all, when you have a situation where you have instance variables that will never change, then it is helpful to make them final, because that clearly indicates that what it is. So in fact, NetBeans suggests that. If I don't have final here, NetBeans will say, hey, you can make that final. And so I do. Okay, and this is an example of a very simple class. Okay, so then, where is it here? So here's an example of how we can use that, basically kind of set all these things like this. this is kind of the initializer thing, but as I pointed out, I prefer to be explicit about this just because the optimal number of ways to do something is 1. And so if I'm instantiating an array, I will always say new and then give the array. Maybe that's just my OCD, but that's between me and my therapist. So so you can leave this off, and Java won't complain. But you can do this only once. I can't assign stuff like this anymore. Right? So so now what is it doing inside? Now these are regular objects. So the only way to instantiate an object that's not an array is with new. And again, because I like to remember as few things as possible, my rule is that if you want to instantiate an object, you say new. There's one exception to that we'll see next quarter, but they involve something called a factory method, but for now, don't worry about that. Just the thing, remember, if I'm instantiating an object, regardless of what it is, I say new. Or I guess our one exception so far has actually been the string. So with a string, this actually instantiates a string containing a single character A. That's our one exception so far. It's a reasonable one because if you think about it, the input to all programs, including the source code, is a string. So strings are special. Okay, so when I run this, we're just gonna, and notice it uses the for each on this because if I don't care about the index, then, and then it's just printing out here that, so here in this world, 95 or above is an A, 90 to 94 is an A minus, et cetera, et cetera. So, right, but that is how, it's a demonstration of two things. One is kind of using this initializer thing, which again, I don't know if you've known that, if you noticed, NetBeans shows a blue when you've ever modified a line. And so if you kind of do something that you don't want, there are two ways to change that. One is if I just want to blow away everything I've done. If you're like me, there have been times when you sit there and you write a bunch of code and you look at it and you say, this is all just a bunch of crap. I want to go back to where it was. Okay, so that happens to me. And if it happens to me, chances are it'll happen to you. So I mean, if you're a more reliable coder than I am, then you never have to undo stuff. But I do. Okay, so here, let's say I've done a bunch of stuff. I realize, okay, this is just a bunch of junk. I want to go back to the way it was. Without something like Git, I'm kind of screwed because, undoing something, can be challenging. Now there is an undo facility, but that isn't 100% reliable. In this case, I want to go back to where this was before I even started mucking with it. So a couple ways to do that. Here, notice that up in the tab, if I just right-click on that and I say Git Revert Modifications, then it says, okay, are you really sure, blah, 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 and I'm sure, and now it goes back to the way it was in the repository. And it can do that because Git kept a copy of the original one, and so when I said revert, it just went back to the original copy and flew over this, yes?
So it just goes back to the last push,
Yeah.
you pushed last?
Yeah, this will go back to the last commit.
Here.
Okay, so if you have stuff that you've committed locally but not pushed, it will go to your local commit. Now it can be finer than that as well, by the way. So let's say I've made some changes, and some I like, and some I want to keep, and some I want to throw away. So let's say this is the one I want to throw away, but there's another one. I don't know. Okay, so let's say this is one I want to keep. Now notice that green is their code for new, so I have one line selected. And so let's say I want to keep this, but I want to remove this. So again, if you just sort of click where it is, and you see I can just delete the added text. And this is, if you do nothing else, this is absolutely invaluable. So I strongly encourage you on all of your stuff to have it in, at least create a local Git. And GitLab, of course, is very useful in the sense that if I work on different computers, and now that we're kind of both on campus and off campus, for me, what that means is that I can work on campus. If I commit it to GitLab, when I go home, I can just pull it from GitLab, and I'm right where I started. The other option is being to kind of put stuff on a thumb drive and carry a thumb drive back and forth. That is the absolute worst way to try to keep stuff. Why? Because thumb drives can easily go belly up. And the other is that when you do that, the chances are at some point you're going to work on the wrong one. It's guaranteed. At least that's what happened to me when I did it that way. And when I discovered version control, it all changed. Okay, so this is all fine. I want to keep that. All right. Okay, so that was the other thing, one of the tweaks that I did, in a class like this, you notice that in mine I made them final. In the books one, they couldn't make it final because they put setters in. And for a class like this, the setter makes no sense. So you know, if my rules are, you know, 95 or above is an A+, 90 to 94, blah, 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 that's, you know, why would I change that? So the thing to remember is that when you're designing your classes, you may have variables that will never change. And if they never change, don't write a setter. You may have variables that others may want to see, and in that case, write a getter or an accessor. Okay, so this is, right, that's what we did. All right. Now the next example, now this is a nice example, a little nicer. And let's see, what did I do on this? All right, so the book is presenting what's more sort of a way of doing UML, which is, you know, this is sort of the standard, and it tries to do a lot of stuff. I'm not going to make you responsible for that, because these, what this is saying is the following. Let's understand. We're going to have classes of DVD objects, and what those represent are these things called DVDs. Now you might want to ask your parents what those are. They're these round, shiny things that we used to have movies on.
Not
I
that
think
young.
most of us are.
So
VHS era.
yeah, I still have VHS. Yeah. So, anyway, so all right. So the idea is that each one of these DVD objects is going to have, you know, this information, and this is useful. Now, what this little symbol here says, if you read very carefully, what this says is there are going to be one or more DVDs in the collection, although I would say 0 or more, because you could have an empty collection in principle. A little quibble, but that's what this symbol means. And I'm not going to make you responsible for that, because it's pretty, I mean, to me it's kind of clear. Because if the DVD collection, now again, same sort of thing, we have a collection which is going to be an array of these DVD guys together with a count, which is going to say how many there are and the total cost of them. And then the main class is going to be this movies one, and again, they say this has an instance of this. Again, what I found is that these things are not as useful as you might think. They can be, but to me, the benefit of UML is simply in telling you what these classes are and how they're structured. What are the instance variables? What are the methods? It doesn't tell you what's in the methods. You need to say that somewhere else. But in just looking at this, for example, I can immediately see what's inside this class. And likewise, in the DVD collection, just by looking at it, I can see what the instance variables are, and I can see what the methods are. Now, they use this is the classic way of representing UML, because UML, they wanted it to represent all kinds of, any language. It's language independent. But if you're doing Java, if you notice, for example, that they put the type after the variable. Now, if you like that, that's fine. If you're writing Java, though, it would be DVD bracket, then collection. So the book is using is classic stuff. So let's just take a look at how this actually plays out. So the thing is that, see, you can take what's valuable is that if I have one of these UML guys, then I can take what's here and directly translate that over into the code. See, so it says I need a title that's a string. I need a director that's likewise a string, a year, which is going to be an int, a cost, which is going to be a double, and then a Boolean, which says whether it's Blu-ray or not. Again, they're giving away their... yeah, so that. Okay, but I can... And what's useful about this now is that if you're designing a class, this is a great place to begin. So I can write down what instance variables do I need, what methods am I going to use, without having to write any code yet. And so I can think about designing the class, or at least the structure of the class, without having to fuss about syntax and semicolons and other, the other annoyances that you have when you're actually trying to write the thing. So you can focus on the design without worrying about the details of how to do it. Okay, and so this just translates directly over. And then we see that the design says there's just a toString, and then in the documentation, it's just a description. So we're using this currency instant format to format the cost, and then taking the description and just kind of putting it together like that. Okay, so that's the DVD. Now, the DVD collection, and this is the purpose of this example, is to illustrate using an array for this. And this is only for the purpose of using an array. If you were designing this from scratch and said, okay, we're going to have this DVD collection class. It's going to contain a bunch of these DVD objects, but I don't know how many. Then is an array the best data structure to use?
A list, or sure, because you can reference the location a lot faster if you're looking for a specific DVD.
Well, if you're looking for a specific DVD, then there's actually an even better data structure called a map, which we'll talk about later in the course, because there you can index them by their title, say. However, the issue here is that because we don't know how many they're going to be, we're going to say, well, we're going to start by making this array of size 100. So what's going to happen when I try to put the 101st DVD in? Okay, so I need to do, and what they have here is actually what you would do if an array was all you had. A better design, and that's just from a design perspective, would be to use an array list. Remember we talked about an array list, because an array list, I can just keep putting stuff in, and it behaves like arrays that you're used to in other languages. Except it's more type safe, because I can only, if I declared an array list, it would look like this. And then as I wouldn't have to worry about what would happen with that 101st. However, this is still a useful exercise because, okay, first of all, one thing that they're doing that is a good practice is to explicitly initialize all of your instance variables. Now, with instance variables, remember, again, that unlike local variables, which must be explicitly set at some point, instance variables don't. Instance variables are assigned their default value when when the class is loaded. You don't have to worry about that. But if I didn't do this, if I didn't do that, then count would actually be okay because the default value of an int is 0. Total cost would be okay because the default value of a double is likewise a double 0. But what would be the value of collection if I didn't do this? It would be null, exactly. You know why? Because it's an object. An array is an object. The default value of an object is null. So if I declare an object as an instance variable and I don't instantiate it somewhere, then it's going to be null. So even though the count and the total cost are not necessary, it is nevertheless a best practice to be explicit about it. Because if I have an instance variable, let's say that's a primitive, that's an int, and if I have not, let's just say this wasn't here at all. Now, let's say that you're reading this code and you're trying to figure out what the programmer's intent was. So in this case, the value of count is 0 because it's the default value. But is that what the programmer's intent was? Or did the programmer just forget? Programmers forget all the time. Happens to me, and it happens to me much more than it used to. It's what, you're all young, but there are 3 things that happen when you get older. The first is you start to lose your memory. And I forget what those other 2 are. I'll be here all week. Okay, so again, I keep harping on this programmer's intent thing. Programmer's intent, to me, is one of the most important things for this, because if somebody is reading this, and whether it's somebody else, like in programs that I'm writing, I have other people kind of looking at it and going, who wrote this crap? Or it's me looking at code I wrote yesterday and saying, who wrote this crap? But it's like, what the heck was I trying to do? What was the programmer's intent here? Or did they screw up? Okay, so that's enough of that harangue. Okay, so here's, but especially with objects, you need to make sure you instantiate them. Okay, so here's what can we do with a DVD collection? Well, we can add one. All right, so now you have two possibilities. So if I were designing this, I would say, well, what if somebody just instantiated a DVD altogether and just sort of gave it to me? I would want that as an add method as well. In fact, that would be the main one. And what this would do would be something a little different. But this is how they did. So basically, here we're inside. When I say add a DVD, it's going to be this title, this director, this year, this cost, and this, and true or false, whether it's Blu-ray. Okay. So let's skip this for a second. If I make it to here, this says, all right, I'm going to instantiate a DVD, put it in where the current count is, add what the cost is to the total cost, and then increment count. Okay, so that should be fairly straightforward. Okay, but here's the thing. What happens when I try to add the 101st? And what are you going to do? Well, what they've decided to do, and this is actually something that Java often does under the hood for you, is they say, well, if I want to add one more, what I'm going to do is I'm going to double the size of the array and copy the old values in. So that's when arrays are all you have to work with, that's pretty much what you need to do. So what they've written is this, where is it? Okay, so notice that it's a private method because this isn't something that you want the user to be dealing with. Now we could have put all this up just up in that one method because it really isn't a whole lot of code. But this is still a better design because it says this task is different than the task of adding a DVD. And the optimal number of things that a method does is 1. So the add DVD method does one thing. Well, it does two things actually, but the main thing it does is it instantiates a DVD and adds it to your collection. In the process, because that could produce an error, so with this, basically, if the thing I'm adding is the length of the collection, that will make it one index more than I'm allowed to put in the array. Again, that's that off by 1 business. Right? So I have an array of length 100, and I want to put in a DVD at index 100. That's an array index out of bounds exception. Again, the off by 1 business. Right, so what does it do? Well, first, I'm going to create a temporary array of length twice as big as the previous one. So in the first time it's going to be 200, and then the next time it's going to be 400. Part of the reason for that strategy is that if you, how should I say it? The alternate would be to add a fixed amount each time. There's nothing totally wrong with that. The reason why they kind of like to double it up each time is that every time you do this, it's going to be fairly expensive. And so at some point, you just sort of have, it's so big that you don't have to worry about it. Okay, so what I need to do is, so now I have a temporary array that has the, it's twice as big, and the values are, the values of temp after this line are null, because DVD is a class. These are out of an array of objects. I've just instantiated the array, but not the individual items. So I need to instantiate those items, but the thing is, I already have a bunch of arrays, a bunch of DVDs that are already in the previous one, and so now. Okay, so now here's a case where the for each will not work for me because I need to set each item in temp equal to the corresponding one in the current collection. Okay, you see that? So I've doubled the size of my array. They're null at this point. Now I'm going to copy in all of the old ones, and I'm going to set them equal. You have to be careful when you set objects equal, but this points the referent, the value of temp DVD is now pointing to the same DVD object as collection at the same index does. Okay, so now at this point, I have this temp array, and that has everything in my collection array, but collection still has just is the old one. So what this does, okay, it's really, I encourage you to kind of really understand what every line in this is doing. What this line does, okay, so when I set an object reference equal to another object reference, now the collection instance variable array is pointing to this temp array, which is now twice as big and has all of the old all the same DVDs in it. Okay, so what this has done is I've disconnected from the previous array, and I'm now pointing to a new array. That new array now is guaranteed to be big enough to put my collection in. So again, if I'm trying to put one more in that I can't put in, I'm going to increase the size when I return from that. The value of collection is now, the array collection is now pointing to an array which is big enough so that this will now work. Okay, so that's...
You could still get an error if the initial collection was just like one DVD long and you tried to add 3 in the same execution, right? Or no, because you can only add one at a time.
Yeah, exactly. Yeah. You say, yeah. In other words, I call this one. Let's say I initialize it to 1. So I call it with 1. Fine. I call it with 2. The second one, it'll double to 2 and put it in. If I call it the next one, it'll say, okay, I can't put that one in, so it'll double 2 to 4. So yeah. But yeah, that's a very good observation. In other words, and you need to be thinking in those terms because of the way that this thing operates. When we will kind of touch on threading, which is when you have multiple threads kind of accessing the same thing. And in that case, what you're raising could be an issue. In other words, if this were part of a multi-threaded application, I could have multiple threads that are trying to do the same thing at once. And then I have some potential problems. So maybe one thread would kind of come in here and maybe make it to here, but then the other thread would start to try to do the same thing. And in both cases, this is not a thread-safe method, in other words. So if I have multiple threads trying to do the same thing, then what you're talking about is something to be raised. But you don't have to worry about that for now, because we'll come back to that.
So the moral of the story is we could avoid all this by just using array list, spice array.
Yeah, if you, yeah, exactly.
Okay.
But as the example though, the importance of this example though is one in kind of the design. So notice that we have 2 classes here. We have the DVD class, of which there are multiple copies, and the DVD collection, which is going to have a bunch of those in the array. The way that the arrays are being manipulated in DVD collection is useful to understand, and a lot of that would be made moot if we just used an array list. So, okay, so that does it for today, and I guess we're back to